This time, we are discussing Unit 2, the Mohr's circle. So recall that Unit 1 is all about the normal and the shear stress equations. And then Unit 2 is all about the Mohr's circle, which is the discussion for this video. So the normal stress and the shear stress that act on any plane can also be determined by plotting a Mohr's circle. So we have here a Mohr's circle. On the x-axis is your normal stress, and on the y-axis is your shear stress. By accurately plotting a Mohr's circle, we will be able to see all the necessary informations that we need even without using the equations to solve for the value of the major principal stress, minor principal stress, normal stress, and the shear stress. So by accurately plotting a Mohr's circle, we will be able to get the values of the normal stress, the shear stress, the major principal stress, and the minor principal stress. So from the figure, we see that from the shear stress axis up to the center of the Mohr's circle, this is defined by the equation normal stress along x direction plus normal stress along y direction divided by 2. We also have here the definition of the radius of the Mohr's circle by this equation. So this is actually the radius. If we are to plot accurately a Mohr's circle, we will be able to get the necessary information, the necessary value, even without using equations. So first things first, we have to be reminded of the sign conventions. So the normal stress is said to be positive if it is compression, and it is negative if it is tension. The shear stress is said to be positive if the direction of the shear has the same direction with the angle of the rotation. And then for 2 theta, the 2 theta is what we see here on the Mohr's circle, this 2 theta. So rotation is always counterclockwise. This is because the direction of the angle is assumed as positive. Then the rotation is based on the positive direction in the Cartesian plane. So now, let's go to the process of drawing or plotting a Mohr's circle. The first step is to identify the coordinates of points x and y. So we have here a figure, two-dimensional soil element. Observe that the angle of the rotation with respect to the horizontal is counterclockwise. So we have here plane AB, the horizontal plane, and then you have your plane EF. So the angle of the rotation with respect to horizontal is counterclockwise. There. Next is to identify the coordinates of point x. The coordinates of point x is simply the normal stress acting on the x direction and the shear stress acting also on this side. So that is your point x. So we see that sigma x is compression, therefore this is positive. And we see that taus of xy, the direction is counterclockwise. It has the same direction to the angle of rotation. Therefore, our shear is positive. Therefore, the coordinates of point x is simply positive sigma x plus positive of taus xy. Next is we have to check the coordinate of point y. So the coordinate of point y is simply the normal stress acting along y-axis and the shear stress acting on this side as well. So this is your point y. We observe also that the sigma y is compression, therefore it is positive, and the direction of the shear is clockwise as opposite to the direction of the angle of rotation here. Therefore, since does not follow the same direction of this angle, it is negative. Therefore, our point y is positive sigma y and negative taus of xy. The next step is to plot the point x and the point y on the Cartesian plane. So on the Cartesian plane, again on the x-axis is the normal stress and on the y-axis is your shear stress. So this is now your point x and then this is now your point y. So the next step is to connect point X and Y with a straight line and identify the intersection with the normal stress axis as point 0. This is now the center of the Mohr's circle. So we have here your point X and your point Y. You simply have to connect the 2 points with a straight line. Now, where the straight line intersects the normal axis, this is the intersection. This is now the center of your Mohr's circle. So next is to draw the circle using the compass. So place the metallic needle of the compass at the center of the Mohr's circle or point 0 and the pen at either X and Y and then draw the circle. So this is the center of the Mohr's circle. And then from here, with the aid of your compass, you can now draw the Mohr's circle. Next is to identify the principal stresses, the maximum and the minimum at the intersection of the Mohr's circle at the normal stress, where shear is equal to 0. So we observe that on the circle, it has 2 intersections along the normal stresses. We recall that the principal stresses, these are the normal stresses that are acting on the principal plane. The principal plane, this is the plane where there is a 0 value for shear. So we have 2 principal stresses, the maximum and the minimum, or the sigma 1 and the sigma 3. So by merely plotting the circle, you can already identify the value of your major principal stress and the minor principal stress. Let's recall, this is your Mohr's circle. From the shear stress axis up to the center of the circle, this is defined by this equation. And then the radius of the circle is also defined by this equation. So this equation is actually your equation for the principal stresses that we used in Unit 1. So sigma 1 is equal to sigma 3. And then the difference is to use the positive or negative. So we use the positive if we are solving for the value of the major principal stress or the sigma 1. And we use minus if we are solving for the value of sigma 3 or the minor principal stress. So since the Mohr's circle, the radius of the Mohr's circle is being defined by this equation, the quantity that we are adding or we are subtracting. So if we add, from this point, if we add the radius, this becomes the value of sigma 1. And if we subtract the radius, so we subtract the radius, this is also the radius, and we subtract, this now becomes the value of sigma 3. Therefore, even without using the equation, and by just merely looking at the Mohr's circle, you can identify the value of your sigma 1 and your sigma 3 or your principal stresses. Next is to measure 2 theta, which is counterclockwise always from the leg radius or from the figure that is from the line 0, y, and project a line from point O towards the circle. So counterclockwise always, we project 2 theta, and if we already have measured a value of 2 theta, let's draw a line from the center of the circle towards the circumference of the circle. Now, where the line intersects the circle, this point has now a coordinates. So if you're going to project the coordinates of this circle, this now becomes the value of your normal stress. And if we are going to project this point towards the shear stress axis, this now becomes the value of your shear stress. So by accurately plotting a Mohr's circle, you're able to get all necessary information like the normal stress, the shear stress, the major principal stress, and the minor principal stress. So this is Mohr's circle, identifying the normal and the shear stress by using Mohr's circle.